Hello everyone, and I hope you're having a good afternoon wherever you are. Now, I'm very excited to get to talk to you this afternoon about Django and async, but first, one small note. I'm doing this from the past, and not just the past in terms of time zones, but like the actual past. What this means is, of course, that future me is in the chat to answer your questions. So if you have questions at any time during the talk, please pop in there and I'll try and answer them as best I can. If you're watching this in even more of the future, on a video on YouTube or some other site, then unfortunately you can't quite do that, but I'm sure you can find me and I'm always happy to answer questions. So with that, let's get on to talking about some async and some Django. Now, before I dive straight into talking about Django and async and the ORM, because it's all very exciting, let's start with a little bit about me first. So for those who don't know me, I'm Andrew Godwin. I have been a Django core developer for, let's just say, quite a while. And in that time, I've done a few different projects, but probably the most notable ones are South, and then its sort of successor, Django migrations, and then of course, most recently, a lot of work on async Django. Now, one small fact is I'm not currently, and unfortunately, in Australia. I am instead in the wonderful world of Colorado, in particular in Denver, Colorado. At some point, when you can get here, I encourage you all to come visit. It's a beautiful place full of mountains, and it has distinctly less animals that can kill you than Australia. But until then, we have to just be content with what we have, where we are now. So let's talk first about the good news. And in case you missed it, with everything that's going on, Async Views have been released. Django 3.1 is out. You can download it, use it today. And in Django 3.1, you can just simply do async def in front of a view rather than def, and bam, you have an async view. Now, this is the result of a large amount of very complex and interwoven work. I have some previous talks, including some from previous PyCon AUs, you can go and look at to learn about that kind of stuff. But essentially, it is to you, the end user, reasonably simple. And so my hope is that's the good first stepping stone into a more async-friendly Django. And one thing to say up front here is that I've always said that the goal is not to make Django async only. The goal is to make Django the place to have a hybrid async world where you can have most of your code synchronous, because honestly it's easier and often it's perfectly good enough for what you need. And then just the performance critical bits or the things that do lots of IO waiting can be in async mode. So the goal has always been a hybrid Django that does both, and async views are a perfect example of that. You can do an async def next to a normal synchronous def for views, put them in the same URLs Py file. They serve off either synchronous or asynchronous servers with some caveats in the asynchronous on synchronous server case. But generally, it just goes pretty well. It's I'm really pleased with how it turned out. And interestingly, one of the very first things when I started talking about all this async stuff in Django about, let's say, 4 or 5 years ago, probably, I think it was a DjangoCon US, but don't quote me on that, was the ordering. This was always a big project. Taking Django async was always going to be difficult. And so even way back then, I'd broken it down to 3 different phases. The first phase was basically developing and constructing a way for Django to run on some kind of native asynchronous platform. That was ASGI. It evolved from the channels project. And that basically came around in Django 3.0. It wasn't very useful by itself, it was more of a foundational thing, but lots of hidden things you didn't see were included in Django 3.0. For example, things like async safety for the ORM was built in from the start. Things like the ability for there to be more than one handler. There's a WSGI handler and an ASCII handler. All that kind of ground laying stuff that we need later on. And then of course, phase 2, async views, was made manifest in Django 3.1 and is now released. And so those first 2 phases, honestly, worked pretty much as I had planned them. There were many missteps along the way and I didn't do things quite the way I'd want to in many cases, but they ended up looking and feeling the way I kind of intended them to, and that's the point. And so now we find ourselves facing down the precipice of phase 3. And in some ways it's kind of unfair to call these 1, 2, and 3 because it implies equal weighting. And that's really not the case when you come to these 3 things. The ORM is honestly most of Django. This is true by lines of code. It's certainly true by complexity and understanding. It is a big, hairy beast sitting in the center of what we know and love. And having to dive into it and add asynchronous support, that is no small task in itself. It's kind of a reason why I've always put off ORM until this last, well, not the last, but this part of the project after the view stuff. First, of course, was the fact that having an async ORM without async views would be kind of pointless, let's be real. But the other part is that it's just a lot of work and I need to get my own async abilities and skills up as part of that process. And I also needed to make sure that things are developing, that the community is going forward, like async is still pretty young in Python's history. So we need to make sure that stuff is all in the right place. And fortunately, now I think it is. So let's talk about what it takes to go into the ORM and change stuff. And first and foremost is Django's API design. Now, I have long been a proponent of like, what makes Django is the way we design APIs for the developer in a hurry who wants to have things work safely. It's always been one of the bywords of Django that if you just do things the default way we suggest, they generally come out working pretty well, pretty stable, and with very few security holes. That's kind of the idea behind Django, is that like, as you get bigger, as your site grows, and I've worked for many sites that do this, you can just remove parts of Django and replace them as you see fit. But the ghost, the spirit of Django still remains. The idea that like, that layout and the idea you can remove pieces progressively and have them all work properly, that's still there. And that's what I love about it. And part of that, honestly, most of that is in the API design. So let's look at some of the features of the Django ORM that you probably all know and are familiar with, that when you come to async, they end up being just a little bit different. And in most cases, we can get around it, but I want you to sort of appreciate some of the difficulties in the way that the async extensions were added onto Python as a language design, the implications those give us for Django and how we design the ORM. So when you come to async, there's a couple of key caveats. And I think the biggest one, I've called this up before for Async Views, is that when you look at a function or a callable, you can't tell if it returns a coroutine. The way Python chose to do async is rather than having like a separate function callable type, instead it says that a asynchronous coroutine function is a function that returns a coroutine object. If you use generators and the yield keyword, this is very familiar. This is why Python core chose it. It's a very sensible move in that respect. And in fact, async was based off generators originally. Now, the problem with this is that, of course, everything's a callable, everything's a function. If it is written as async def in the actual source code, then there's a special flag set on it that says, yes, this function object actually is a coroutine function. And there's a thing called isCoroutine function in Async Iter that will tell you this. But that's not true of all functions. If you just write a standard def function that returns a coroutine, that's still a valid coroutine function that we should do async things with, but we can't tell it's one from the outside. So like, here on screen right now, these are both perfectly valid coroutine functions. They essentially return the same kind of thing, but one of them you can tell from the outside before you run it what it does, and the other one you can't tell from the outside what it does. And what comes down to at the end of this is that Python doesn't have a separate call and async call method. It just has a call method. And so what this means is, as a function on the other end of that contract, you don't know if the thing calling you is expecting a coroutine back because it's in like an asynchronous context, or if it's just a sort of normal old Python function that wants a normal synchronous result. And so what this means is you can't have one function that does two things. So you have to namespace every function you're providing to have both a synchronous and an asynchronous variant. Let's take a look, for example, at the get method on managers in the ORM. Now, I would love to be able to say, await model objects get ID, but we can't do that because the get method has to only be one of synchronous and asynchronous. And of course, we're not going to break anything here. So instead, we have to namespace it. Now, this particular namespacing is, shall we say, pending. We're still not quite sure how to separate it out properly. It might be .a, it might have like get underscore async. Whatever this ends up being, it will be something like this. But the idea is that the async variants will be named differently and you will have to access them differently. This is just something thrust upon us by the way Python's async is designed. There's a trade-off. Like, it's a good design in many ways. This is one of the few unfortunate cons from it. So this is what we get in terms of functions. This is not too bad. In many ways, I do like this because it means if you are calling an asynchronous variant, you can read through your code and make sure that, yes, we're definitely calling all the async functions, because the other kind of weird side effect of Python is that if you call a synchronous function in an asynchronous context by mistake, then it just runs. And it runs really slow and blocks your whole process, but it doesn't throw an error. And so it's actually quite nice to have an extra safety barrier of, these are the definite separate asynchronous functions that definitely aren't going to block. Because the failure mode of calling synchronous stuff is your website gets mysteriously slow and no one knows why. Until someone finally goes, somewhere deep in this function, you've called get the wrong way. So that's one of the sort of trade-offs you have to deal with. Now, the other main one, and this is maybe the biggest blow in some ways of Django's design, is you can't do asynchronous attribute access. Now, if you're not familiar, in Python, you can override objects so that the attribute access, when you do .name, is run through a custom function. And this is what Django does for a lot of its fields on models. In particular, when you have a foreign key field on a model, if you haven't loaded it, when you do .foreignkey.name, in the background, Django will quickly go, oh, and go and talk to the database, query that thing for you as a single GET query, pull it back, load the object into memory, and then serve you the result of that object. Now, of course, the thing with async is we're not allowed to do any I/O outside of an asynchronous context. And we can't do attribute access asynchronously. So what that means is we are not allowed to do that background database fetch in an asynchronous mode, because if you did .name, or sorry, .foreignkey.name in an asynchronous context, and we left the old synchronous code in, Django would, again, block the whole process, run a synchronous query, pull it back, and that's not what you want. So this stung me for a while, but then one of the nice things is you probably shouldn't be doing this anyway. And so if you do a query like this, again, async get function, like the way this is written is, still being decided, but imagine it was written like this. This would error. Basically, if you are trying to access a foreign key you didn't fetch, in future, if you are in async mode, and only in async mode, Django will throw an error saying, hey, you can't do implicit access during async mode, please use select related. Because what you can do is you can do this. And honestly, you probably should be doing this. There are very few edge cases where you don't want to select related on a query where you're pulling foreign keys. So in many ways, this isn't too much of a problem to have because we're kind of encouraging the right thing to do anyway. Now, of course, we'll still allow attribute access in synchronous mode. It'll work perfectly fine. We can tell inside functions what mode the outside is in at least. But in asynchronous mode, you'll kind of have to use select related. There are some very, very terminal edge cases where the Django ORM and query logic doesn't handle select related right. And for those, I apologize. You may eventually have to break out and do your own separate query inside a for loop. But for 95% of all cases, I think you'll find that being forced to use select related is probably a good thing. And in fact, I'm almost tempted to have this option we can just turn on all the time where Django just doesn't let you use implicit attribute access at all. You always have to use select related because I can think of several projects I've worked on where I have made that mistake no number of times, just a huge amount of times, and pulled up Django debug toolbar and said, why are there 400 queries? Oh, I forgot to, I'm doing the query inside the loop. So that's kind of the thing we're going for there. So that's kind of the bad stuff, and let's go on to the good stuff. So some of the nice things are there are nice analogs of some of the things we're used to in synchronous world in the asynchronous world. Maybe my favorite one of these is iteration. Now, when you call for or iter or any other sort of iteration primitives in Python on an object, it again looks for a special method, in this case, _iter. And the nice thing is there's an async version of this called _a_iter. And so on query sets, which of course is most of the things you're iterating over in the ORM, we can supply both. And when you do async for, which is the async version of for, it can call the a_iter method rather than the iter method, and we can give you that lovely full asynchronous path to database and not block the process. So what this means is if you're writing asynchronous code, again, you can just basically take your synchronous for loop, make sure you put select related in the main query, and then change for to async for, and generally it will mostly work like you want. And this is one of the really nice features. There's other things like async with and other things like that too, but this is maybe the most important one for the ORM, because thinking about again, API design is crucial, right? We want to make sure that the API is designed in a way that people appreciate. This is part of that. And so I think it's really nice to have the core looping through iteration part of Django be honestly pretty similar between both worlds. So let's talk a bit about the plan to make all this work. And at the top of this, I want to put big disclaimer. This is a plan. I and a few others have started roughly planning this. Not much code at all has been written yet. Certainly none of it's been committed. This is all subject to change, but this is kind of based on what I've been poking around with, what I think the best path forward is. So again, let's look at some phases. You can tell I've been doing principal engineering for too long. I now do project planning in phases. 3 phases here again too. The first one is to have an asynchronous model API. So in my opinion, the key thing is to get the API design locked down so you can start writing apps using it. Even if behind the scenes, you'll see in a second, is not quite the same as being pure async, The idea is that if you have async code, that you can write async views with async ORM access in them, and it all looks and works nicely, and crucially is safe. We'll get onto safety in a bit later, transactions especially. Ooh. Secondly, once we've made that sort of top level async friendly, we then go into the sort of the core guts of the Django ORM, which is the query internals and the compiler and other things like that. We make those async friendly. Now, the nice thing is a lot of that stuff is CPU bound, like the compiler, doesn't need to be told much about async at all. Mostly it's the path through the query, from the query set into the connection that needs to be made async. I'll show you a diagram in a second of that. And then finally, once we've made that top part all asynchronous, we then have to look at the database adapters. Now, as you'll see in a bit, we don't have to make those asynchronous, but if you want the best performance, and some databases already support this, you do want native asynchronous performance at your database layer as well. So let's diagram how this looks. So phase one, as I said, you take those sort of user-facing APIs, which is generally the base model class, the query set class, and the manager class, or the base manager class, and all the things come off of it, and you make those have the async varies, async understanding. So things like Iter, like I said, for looping over in for loops, async get, async update, async create, like basically async versions of all the operations that cause a change to the database. Now for query set, this is surprisingly few things, because whenever you do filter or other things in a query set chain, they're all lazy. We don't have to change those. The only thing that actually does anything in a query set is when you finally iterate over it. So in fact, query set mostly stays untouched. And there's a few things in there that do cause an actual evaluation. I think values list does it, for example, but most things don't. So we can keep those all the same. Not much need for like async namespacing everywhere in our query sets. So that's phase one. And as you can see here, the rest of Django, below those sort of initial user-facing things, is running threaded. And essentially, this is kind of a version of what you can do today. If you use async views, you have to basically take your ORM code and wrap it in a sync to async wrapper that we provide as part of Django. And this is doing that in a sort of more formalized, more safe way, where rather than to like make a separate inner function and decorate it and put it in, feed it in properly, you can just call the error in a way you think is correct from an async world, and Django will handle the async handoffs, making sure the threads are good and making sure everything runs correctly. It is, of course, still threaded behind the scenes, but if you're doing, say, 10 database queries in parallel, Python's threading overhead isn't going to hurt you very much. You're still going to get massive increases. Like imagine if what your site does is it does 3 or 4 like medium length complex queries that don't depend on each other. In the future, you can literally pull all of those and run them all in parallel in an async view and then get back the result in a quarter of the time. And that's the kind of real benefit you can see. And that's honestly one of the reasons I think the ORM is the place where async's really going to shine. But let's talk about what we do after we've got this one running. So this is probably the first step and probably will be the first thing in a Django release by itself. And then we need to go in and make it sort of a bit deeper. So we bring down that level of where the async boundary lies and make it the other side of the query. So now all the Django's internal query logic and execution and mapping is all done with asynchronous friendliness in mind. It may not be pure async, but it understands how things interact. And then the only thing running threaded is the, sort of the database adapters. Things like when you sort of type in your database setting, like those bits of code, like, oh, here's the MySQL adapter, here's the Postgres adapter, and so on. Those will still run async. And then finally, we will then pull the boundary all the way down and make the whole thing asynchronous. Now, there is a big asterisk on this one. The very bottom of this diagram, right there, is not controlled by Django. The database libraries are third party. And we have to make sure there are good enough, mature enough third-party database libraries we can write against to make this work. That's one of the reasons we know we're never going to have to be able to drop threaded support entirely. In fact, in many ways, we may never get to phase 3, and that's perfectly okay. Most of the performance gains you're going to see from the async ORM are still being present when it's fully threaded. And I expect that we will get full async adapters in time, maybe not for Oracle, but certainly for Postgres and MySQL and SQLite potentially, though it's single file threaded, so it's a little bit different. And one of the other reasons this is difficult too is that Python has a database API standard. It's called DB API 2. It's been with us for a very long time now, and it's great. But the problem is, like WSGI, it's not ready for an async world. And honestly, for very good reasons, most database library authors already have too much to do on their plates and don't want to have to talk about another kind of standard and then implementing it and then all agreeing on how it works. And there's lots of, so this is kind of what belies all of this. So at least in the short to medium term, it's going to be Django's job to wrap all that up for you. I do expect we'll probably ship at least in the medium term, a pure asynchronous backend, probably on a different library than the ones we have right now. For example, for Postgres, there's a couple of nicely maturing asynchronous libraries for talking to Postgres, but they're not PyCon2. And so we would have to go and change a lot of our code and the assumptions about how PyCon2 works. And if you have looked at Django's bug tracker for any length of time, you will know that most of the bugs are in weird edge database cases that it is our job to fix. And I don't want to just throw away those fixes. That's kind of where it becomes, interesting. But I need to reiterate this: databases via threads are not terrible. Threading is bad; like it's not going to be scaled indefinitely. But if you're just booting them up just to run a query and shutting them down again, you can have a pool of 10 to 20 threads that significantly speeds up your application's performance. And of course, in async mode, you can do queries and also do API calls to the modern world of very heavy microservice architectures. Having asynchronous HTTP or gRPC or other calls, incredibly useful as well. In my experience, most large software design, if you are a big company, is spent waiting on other things. So as you get bigger, that gets more important. But even as a small shop, I think the ORM is where it will shine, where you can do those queries quickly and understand them and see how they go. Now let's talk about the one final sort of fly in the ointment here, and that is transactions. Transactions are very tricky. And the reason for this is transactions run on database cursors. And database cursors are one per thread. This is part of Django, there's a big thread local in the middle of it. If we are going to support transactions, we have to be able to support them all in one thread. And this is a problem when you're going from async to sync world. Internally, when you go from an asynchronous context to a synchronous context, Django boots up a separate thread and then runs stuff in the separate thread and then brings it back to the main asynchronous thread when it's done. What that means is we can't share transactions across that boundary. So I'm not quite sure what the solution here is yet, but it's probably quite likely that when you use transaction.atomic, it won't cross over asynchronous synchronous boundaries. And we're going to have to work out how to signal that so it's pretty safe. It may be an implicit error, maybe having to wrap it in a certain way, maybe a different version of atomic that is async compatible. But that's kind of one of the key things of it's going to really suck unless we find a good way of doing it. There is some promising research into getting around this from some other database libraries I want to look into, but for now, I expect this will be maybe the main sticking point of the first part of that conversion of making an async-friendly API. The thing to mention is some things just don't need async. I'm honestly very glad that migrations doesn't need it. It runs once in the background synchronously. It does not need performance improvements in that sense. It all runs in serial anyway. So we're going to leave those bits well alone. Introspection is another thing. A lot of the internals of fields like conversion to and from Python, also the same. Honestly, the service area that we have to make async isn't too bad. It is very tractable, or I wouldn't be here giving this talk saying it's totally possible. But it is still a lot of it. So thankfully we can ignore some pieces. Again, we can ignore things like forms right now in compared to views, but other things we have to tackle. So what's first? What is the first thing we're working on here? Well, before all those phases, we need to decide on what that async API design looks like. And I'm not a fan of designing in a vacuum. I want to do it sort of with the real thing, with a concrete thing to play around with. So we need to do that as well. We need to grapple with transactions. And again, that's kind of part of the API design and make sure it fits and works well. And finally, I need to figure out the thing that underlies transactions, which is async connection management. How do we pull things and have multiple connections in one async thread or multiple separate connections to separate threads? Do we share them across sync threads? There's a whole world of things. Some adapters don't like other things. SQLite's especially sensitive to this. It's kind of a pain. But on top of all of this, the thing to remember is async is only important for IO-bound code. This is one of the reasons we're doing the ORM. It's not important for things that are CPU-bound doing computation. Python is still putting them on a single core behind the scenes. But things that are IO-bound, it's super important for. And that's why the ORM is a huge part of this. Django is the ORM. I've used the ORM so much over my probably 15 years at this point using Django. And it is a huge win for us to make it async, especially if it's easy. The ability to write a query quickly and easily that just can run in parallel and it's safe and you get the results back. To me, that's the promise of what async Django is. And so I'm hoping that's what we'll get. There's a lot to come. I'm not going to commit to anything being in 3.2, but I'm soft aiming for at least that first phase to be in there. But of course, we live in interesting times, so we'll see. But yeah, thank you very much for listening to this. I hope you're excited about async Django as much as I am. And hopefully I'll see you soon somewhere, talk about async Django. And if you're interested in helping out with this kind of stuff, please come to the Django forums. We're happy to discuss it. We have a whole async forum there to discuss things. But until then, thank you very much, and I'll see you around.